I was thinking about miter saws recently and got to thinking about how they determine the cut length for a particular model of saw when designing. In this problem, we have a miter saw that we want to find the plunge depth, or how far down the saw must move into the table in order to cut a length of 8 inches of material with a saw diameter of 12 inches. How do we go about solving this one? Our mission is to will a right triangle into existence, so half of the saw diameter is 6 inches. We can place this dimension where the outside of the saw blade meets the saw table, then goes towards the center of the saw blade. Now we can cut the cut length in half of 8 inches, so it is now 4 inches. Hey look, we got a right triangle. Next we can use the Pythagorean theorem to solve for our B-side length, which is the distance from the table surface to the center of the saw when fully plunged. The Pythagorean theorem is a squared plus b squared equals c squared. Rearranging to get the B-side length to one side and plugging in our numbers, we get a B length of 4.47 inches. This means that we can cut material that is 4.47 inches minus the bolt holding the saw in place radius tall, and that is 8 inches wide. This is all assuming the guard around the saw does not interfere. Looking at my graphic, it looks like it would. Now to get the plunge depth, we can take the B-side length minus the radius of the saw of 6 inches, and we get a plunge depth of negative 1.53 inches below the saw table surface. One thing worth mentioning, if your saw has a gap, then it goes to the cut distance. You'd have to add this gap distance to the cut distance in order to do this calculation. That concludes this video. Hope that I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.